I'm Jay Dennis, and I'm going to talk about forecasting competing risks for Navy personnel management. Now, predicting manner of exit allows us to think about early interventions that can steer individuals toward better outcomes. So what do I mean by better outcomes? Well, maybe we want to retain these individuals, or maybe flag someone to intervene to prevent, for example, say a predicted dishonorable discharge. Now, our broader goal is to build a better model of how demographic characteristics, personal preferences, and service preferences relate to attrition. I'm only going to address some of these today. Specifically, I'm going to talk about predicting the manner of exit in addition to the timing of exit. Now, IDA developed a tool for forecasting when an individual will leave service. We call this the finite interval forecasting engine, or FIFE for short. The base capability of the FIFE does not provide any information regarding how service members exit, such as honorable discharge, medical reasons, things like that. But if we can predict binary outcomes, then we can predict outcomes with more than two categories. So we extend this capability to predict the manner of exit, and we incorporate this into a competing risks framework. Now, I should note here that these are forecasting exercises. We're simply looking to predict how individuals will attrit. This doesn't make any causal statement regarding why an individual attrits. So first, let's talk about competing risks and how our forecasting fits into that framework. Base FIFE only allows us to forecast when an exit will occur without consideration for the type of exit. Competing risks is a framework that accounts for the type of exit. This extension is going to incorporate competing risks. Now, to illustrate this, we can look at the difference between the two tables here. Now, note this data is notional. In the top table, we only predict the probability of exit at different times. You can see that the individual represented in this table is not likely to leave in 2022, but is likely to leave in 2023. In the second table, we predict both the time of exit and the type of exit. So we can see that the individual is likely to leave by either an honorable or administrative discharge in 2023. So we have more information. Now, why do we care about competing risks? Well, prediction of the type of exit in addition to the timing of exit can facilitate things like targeted retention efforts and career trajectory interventions for at-risk individuals. So for a little better explanation of competing risks, let's imagine another made-up person's career trajectory. In particular here, we can think of two different realities, with one of them generating the data that we observe. The dark blue squares with the thick solid lines show the observed career path. The green with the dashed lines show the path that would have happened if the individual had remained in period 2 instead of exiting. The slim dotted lines here indicate outcomes that do not occur in either of those realities, but of course they may occur in some other reality we're not showing here. But the type of exit here, honorable and administrative, compete to be the observation regarding exit in the data. That's why we call them competing risks. So equivalently, we can look at a particular time period, say t equals 2. The possible courses of action for the individual are remain, honorable exit, and administrative exit. Each of these compete to be the observation of the data for that time period. This gets at the cause-specific hazard, which I'll talk more about in a minute. And traditionally, this terminology indicates that staying isn't a risk and all the possible exit states are risks. We see this terminology in medical studies where exiting a data set can mean dying and the states are different causes of death. So the types of exit are the risks that are competing to be observed in the data. Now, in our data, we see a bunch of people and their associated solid black lines and dark blue rectangles. And some outcomes are right censored by the last time period in the data, so we don't observe anything after censoring. So we can write down a more formal definition of the competing risks framework. The subscript I here indicates indexing by individuals, and there is a mutually exclusive collection of outcomes, each with its own time of occurrence. For example, outcome 1 might occur for individual I at time t1 equals 10, and outcome 2 could occur at time t2 equals 12. We wouldn't observe outcome 2 in this case. Additionally, each outcome can be censored. We denote this with the subscript 0. We only observe the thing that occurs first, either censoring or the first outcome and the associated time. The idea here is that if we see some event K occur, then a different event could eventually occur had K not occurred. Now, the cause-specific hazard is the item of interest. This is the joint probability of exiting at a particular time and in a particular manner. So for example, honorable exit in 2023. Fife estimates this with two different families of models. The first is for the probability of exit and comes from the base Fife capability. The second is the extended capability where we estimate the type of exit conditional on exiting at a certain time. Now this conditional on exit at a certain time is important because it lets us combine these probabilities after the fact into the cause-specific hazard using the rules of conditional probability. Note here that XT is a collection of predictors. For the models here, you can think of a traditional logit or multinomial logit, with a difference being that we use a tree-based modeler from LightGBM to choose the functions F and G. Using a tree-based modeler is nice for forecasting because we can take advantage of the flexibility that tree-based models offer. We can visualize these probabilities with the cumulative incidence function. The cumulative incidence function tells us the cumulative probability of exiting into a particular category over some forecast horizon. You can see an illustration of a cumulative incidence function here. The individual indicated on this graph has a 20% probability of leaving due to administrative discharge within 12 months from now. This individual also has a 30% probability of exit due to honorable discharge over the same time period. All right, so now that we have some preliminaries out of the way, let's look at a case study. We apply the competing risk extension to active duty enlisted naval personnel over the time period 2015 to 2020. There are some other items we discuss in the paper that we omit here due to time constraints. We're going to use a 20% sample of the population from DMDC, which leaves us with about 94,000 people and 4 million observations at the monthly level. Covariates that we use to predict timing and manner of exit come from our DMDC data holdings, including the active duty master file, ADT, and other data sets. These predictors include standard demographics, family characteristics, service retention bonus eligibility, time to end of contract, and many other things. The most complete source of exit data on service members comes from ISC and SPD codes. These are inter-service separation codes and service program designator codes. But a big takeaway from this study is that categorizing and forecasting exit type is hindered by data quality issues. In general, categorizations end up with a lot of codes classified as unknown. And then on top of that, we have to worry about the codes being used differently from how they are described in the code books. For example, a code may indicate both court-martial and move to another service or component, which seems unlikely. And that's not even accounting for how the codes are actually used in practice. So since no categorization is going to be perfect, we propose a few different categorizations of exit type based on SPD and ISC codes. Our hope here is that having several exit type categorizations will provide some useful insight. I'm going to talk today about results for service desire, service members desire, and exit group. But there is another outcome categorization that we show in the paper that describes the service member's choice as voluntary or involuntary, but I'm not going to talk about that today since it's not really going to add much to the discussion. Now, we mentioned at the start of this presentation that we wanted to construct a tool that would help us with targeted interventions. So we use this framework to find an individual that might be of interest. In the paper, we discuss some other use cases like exploring differences between groups and looking at forecasts aggregated to the unit level to flag struggling units. But before we start talking about this individual, I should mention that we don't want to end up in sort of a minority report kind of situation where we can act on individual forecasts to, for example, preemptively boot somebody out of the service based on a prediction of future court-martial. To some extent, the technology is there. So we really need to be careful how we guide its use. Using individual forecasts to target retentions at those individuals brings some legal, moral, and ethical concerns that we don't address here, but they are important. In particular, acting without consideration to these concerns can lead to, for example, unintended discrimination. Now, with that said, let's look at this individual's forecast. The larger graph shows the cumulative incidence function for an individual that's forecasted to exit with high probability into an unsuitable state in the next few years. Compare this to the smaller graph, which shows the naively pooled forecasts, and we see that unsuitable exits are typically low probability, with release general being the most likely exit state. Keep in mind here that the unsuitable category is reserved for things like court-martial. This should throw up a red flag that we probably want to look into this individual and determine if some type of counseling or other intervention is needed. Note that we can't determine the potential cause of the unsuitable exit here, but we can use this as a flag that tells us to check on this person. So when I saw this, I immediately wanted to know more about this individual, and there are more people like this. But we can't discuss further details about individuals in this forum due to privacy concerns. Similarly, we can find individuals who have a high predicted probability of exiting into both a service desire equals want to keep and member desire equals want to leave states. It looks like this individual might have a contract decision coming up in the next 2 years. And this individual will likely leave despite the Navy wanting to retain this individual. We should be careful here to note that using these forecasts to target this individual with a retention intervention, and I use the term intervention broadly here, this can bake in some discrimination issues. For example, we're just forecasting exit type here, and it could be that the forecasts could be picking up on the propensity of a certain race to exit while wanting to stay. Consideration of these legal, moral, and ethical issues are needed to guide how to use these forecasts to inform interventions. Note that we are only forecasting the probability of these states, and we can't say anything about their causes. Also, we're treating the outcomes of service and service member desire as independent here. In reality, those are latent bivariate outcomes that require exclusion restrictions to disentangle. We talk more about this in the paper and provide a methodology different from what we talked about today with the FIFE to disentangle these outcomes and potentially their causes. In conclusion, we've expanded IDA's finite interval forecasting engine forecasting capability to forecast exit into multiple states. The competing risks framework allows us to forecast both timing and manner of exit of individual service members. We demonstrated its use in flagging service members for interventions. We talk about other use cases and observations from the case study in the paper. In particular, we compare forecasts for SRB eligible and ineligible sailors. And we address some limitations with this framework, namely disentangling the latent bivariate outcome by introducing another modeling framework. And finally, I just want to reiterate that further study of the legal, moral, and ethical issues is necessary in order to guide appropriately the use of this type of a technology. So to wrap up, I'm Jay Dennis. This work was done at IDA, and thank you for your time.